Welcome, everyone, and good morning. My name is Gail Sinatra, and it is my distinct honor and privilege to be introducing the keynote today by Dr. Roger Azevedo. The title of his talk, as you can see, Advancing Metacognition and Self-Regulated Learning with Multimodal Data and AI-Based Advanced Learning Technologies. And if you don't understand what that means, that's okay, because he's going to explain it to us. Roger is the Pegasus Professor at the University of Central Florida in the School of Modeling, Simulation, and Training, where he serves as the director of the Laboratory for the Study of Metacognition and Advanced Learning Technologies. And I'll remind you what Pegasus means. Pegasus represents various positive qualities, including freedom, inspiration, creativity, and transcendence, and they certainly picked the right professor for that role. Roger received his Ph.D. in educational psychology from McGill University in Montreal and completed his postdoctoral training in cognitive psychology at Carnegie Mellon University in Pittsburgh in the United States. His main research areas include examining the role of cognitive, metacognitive, affective, and motivational self-regulatory processes during learning with advanced learning technologies such as intelligent tutoring systems, hypermedia, multimedia simulations, serious games, and immersive virtual learning environments. Roger has served as editor of the Metacognition and Learning Journal, has served on several journal editorial boards, and his research is funded by the National Science Foundation, the Institute for Education Sciences, the National Institutes of Health, and the Social Sciences and Humanities Research Council of Canada, and at least one of those agencies still exists today, and that's the Canadian one.
Oh, okay.
It's true. He has published over 300 peer-reviewed papers, and Google Scholar notes his work has been cited over 28,000 times. Roger is a fellow of the American Psychological Association and the American Educational Research Association, and he is the recipient of the prestigious Early Faculty Career Award from the National Science Foundation. He is a citizen of both the US and Canada, and that Canadian citizenship might come in handy soon. I've learned a few very interesting things about Roger as a person preparing for this introduction. For example, I have learned that he is a connoisseur of port and an excellent cook. But the most interesting thing that I learned about Roger is that he is a black belt in Shaolin White Crane Kung Fu.
Wow. Where did you dig that up?
I have my sources. And an excellent kickboxer. So if you don't appreciate his keynote today, maybe don't mention that. And with that, it's my honor and privilege to welcome to the stage Dr. Roger Azevedo.
Thanks so much. Thank you so much, Gail, for that wonderful introduction. Really appreciate it. I'm wondering where you dug up all the dirt. But good morning, everyone. It is my distinct honor and pleasure to be here, to have been invited. I'd like to thank the organizing committee and EARLI for inviting me to give one of the keynotes at this year's conference. And so with that, let's get started. So the title really is Advancing Metacognition in SRL, for those of you who are not part of the team, if you will. SRL is Self-Regulated Learning, and multimodal data. So even though we focus obviously on performance measures, learning outcomes, of different types, really want to focus today is on the utility and the advances that we've made in terms of multimodal, multi-channel data, in terms of understanding the temporal dynamics of these self-regulatory processes. And you're going to see the acronym CAMS come a lot. So CAMS means cognition, affect, metacognition, motivation, and then depending on the context, we also add the S, which is for social. And that could be human-human or human-machine pedagogical agent. And AI-based advanced learning technologies, because some of us also, when we were trained at McGill and continue our training at Carnegie Mellon, we have been trained in the field of artificial intelligence and education. It's not just Gen AI, folks, okay? There's an entire field out there, all right, where we have dealt with these issues in terms of, can we understand what those self-regulatory processes are, and then how do we embody some of those, not only in terms of the human embodying them, but also a learning technology. And by learning technology, we're also going to talk about what some of those are. And like Gail said, this work is, I'll just be very honest, is very expensive. It requires large teams of interdisciplinary researchers. I'm very fortunate to be, along with my team, I have 3 team members here. I got 2 of my postdocs, Megan and Matt, and also one of my master's students, Cameron, who are also very instrumental. The rest of the team is back home. But this requires large interdisciplinary researchers and teams to do this. So we usually represent psychology, we usually computer science and engineering. Those are the key. And then we work with the stakeholders. And you're going to see a lot of different types of stakeholders, either K-12 teachers, students, middle school, high school, but it can also be patients, a cancer patient, for example, or an oncologist or an emergency medicine. We work across different learners, contexts, tasks, domains. You'll see a lot of that. And yes, like she said, many of the leading funding agencies and some Canadian also. And then, of course, currently we also have the Cella project, which is led by Sana. So Sana, Maria, Inga, and Dragan, we have been collaborating for over, oh my gosh, it's probably more than a decade now. And that is the Cella project, which you probably have heard a couple of talks, and that's funded through the Jacobs Foundation. So let's get started. So in terms of an overview, right, just to remind everyone that we don't design technology based on intuition, okay? There is a science of learning, okay, if you look back in the history of educational psychology and learning sciences. So we are not only using science of learning principles, but we're also advancing and contributing to the science of learning. In our case, it's science of learning with advanced learning technologies, okay? And that could be anything from intelligent tutoring systems, hypermedia, multimedia, serious games, simulations, high-fidelity mannequins, okay? And what you're going to see both now in the next hour and a half, and also if you were here yesterday or be here tomorrow, is some of the work that, as we advance AI, is the role of human digital twins. What is a human digital twin? And also simulated learner, okay? So, and then in terms of metacognition self-regulation, I'm not going to go into the definitions because that would take an entire semester to do that. But focus, basically, metacognition self-regulation is important for academic success and for learning, for being adaptive. What is an adaptive human? And then to think about some of the high-level aspects of metacognition that, you know, it's awareness, it's monitoring, it's regulation. And regulation really is the SRL part, but also the evaluation, reflection, and adaptivity, right? As a human, if we want to be adaptive and self-regulating, we should be learning from what we do, how we perform, et cetera, and we should be able to adapt so we are better successful the next time around. Obviously, some humans can't do that, right? There's particular challenges, and therefore we use technology both as a research tool, as an educational tool to support and foster self-regulation and metacognition. And then if we think about all the verbs, right, they should about ending ing, right, is we're trying to induce, detect, model, track, support, foster, reflect, explain, simulate, because we're in the modeling and simulation world, and also teach and train metacognition, self-regulation, not only in humans, but also in artificial agents. And we'll talk a little bit about that. And then thinking always strategically that the use of any of the technologies, the ALTs, as you'll see, right, are always research tools and learning tools, and they go hand in hand, okay? We embody what we know about metacognition in those tools to foster and support. If they can't self-regulate, that we learn, and then the question becomes, how do we make those systems much more intelligent, right? And we can have an entire, I mean, some of us have spent 30 years talking about what is intelligence, where does it reside, et cetera. In terms of multimodal data, so those are enough familiar. So typically we have log file data, concurrent think-alouds, eye movements, facial expressions, physiological sensors, et cetera, right? Depends. And you're going to see a lot of these examples. And we ask the question, how much multimodal data do we need to really fully understand metacognition, self-regulated learning? Okay, to understand it as a psychologist, right? So that then if we're designing instructional implications, then we know how to embody those implications, right? For example, adaptive scaffolding in these adaptive learning technologies. And the question becomes, are they effective, right? So CAMS, that I told you about. And then we're gonna walk through, I'd like to end this with discussing some of the conceptual, theoretical, methodological, analytical issues that we're still facing in the literature, which good for us because, you know, that means we still have a job, all right? And then we'll finish up with future directions. So let's get started. So self-regulation, right, at the core, we're psychologists, right? We always talk about operational definitions. So the basic question is, what is self-regulation or metacognition, right? And folks go from anywhere from the neural to the social, right? If you remember back to Newell's bands of performance, right? We include that. But we also need to include contextual processes, because sometimes the context also not only induces, but impacts your ability or your lack of ability to express agency and self-regulation, right? And the question becomes, how do we measure, right? Well, we take an approach where we triangulate self-report measures of all types, learning outcomes, performance measures, but then really focus on the multimodal, multi-channel data. Because I'm not just interested in people's perceptions of how they are motivated, right, or how they engage in metacognitive monitoring. We actually want to study it in real time as they're doing it or not doing it, right? And this is where the multimodal data is extremely important. And the analysis, right, this is what creates our bottleneck. So we have to collaborate not only with ourselves, but also other colleagues, especially in computer science and engineering, and also now in terms of artificial intelligence, because there are many techniques that are being advanced in pure AI that can also help us advance our field, okay? Because we're somewhat limited by the types of statistical analysis that we typically engage in, whether it's learning science and educational psychology, right? So anything from mixed methods, qualitative, quantitative, a lot of people using machine learning, but there's also computational model. And we're seeing an emergence, especially in ed psych, of the use of complex dynamical systems as a way to model the temporally unfolding self-regulatory processes that a human generates that you capture multimodal. And because I'm in the school, or we're in the school of modeling and simulation, we add two other aspects, is how do we model SRL? Because it's not just saying like, hey, you can't engage in SRL, we want to be able to model it, right? So we can do things like diagrams that can be embedded in learning technologies, okay? But more importantly, from a purely interesting and advances in AI, is we're starting to use more sophisticated human digital twins and simulated learners that actually can model these processes for a learner, so you can actually see them in action and then practice and get feedback. And also to simulate those, because those are extremely important. Some of our new grants use Gen AI conversational agents that actually generate synthetic data. So this is multimodal data that no human has actually collected, okay, or generated, but we're able to model the hypothetical multimodal, multi-channel data that, for example, exemplify metacognitive accuracy in terms of monitoring. So these are some of the areas we look at. So we do everything from classroom research, where we have lots of students. We can be 34 students, or we have a student that is pulled out. So the student there you see is actually learning about chemistry in a chemistry lab, or, for example, we're using high-fidelity mannequins in terms of training, for example, clinicians. And we have multimodal data. The top right is where you see the labeled context, and we'll talk a lot more about that. So we are theoretically driven. We're psychologists. In our work, one of our challenges is that it's not good enough because it doesn't account for everything that we're trying to understand by using one model. So we tend to use multiple models, whether they come from cognitive psychology, meta-memory, meta-comprehension, learning sciences, educational psychology, et cetera. So for example, if you know, here's a snippet of some of the models that exist that we tend to use in our work, right? Everything from a very basic but fundamental meta-memory model, right, of meta-level and object level from Nelson and Ahrens that goes back to 1990, right, all the way to the model that we tend to use and keep using because it is very relevant to the work we do, which is the Winnie and Hadwin model of information processing theory, because they treat self-regulation as an unfolding process, so it really matches well with the multimodal aspect. To any other model, for example, the one you see in the middle that's colorful, the second one on the top is a metacognitive architecture. So for example, our literature in ed psych, learning sciences, et cetera, never really talks to pure AI, but we have metacognitive architectures. Why are we not borrowing from the computational modeling aspect and bridging those together? All right, so we're doing that. And so it's not good enough just to account for cognition, metacognition, because our learners, right, whoever they are, also express motivation and affect. So we also borrow, right, from affect dynamics, for example, the Grace and Mello that you're probably familiar with, clinical psychology, right, emotion regulation that comes from clinical social psychology that grows, et cetera. So the question becomes, how do we take all these models and integrate them? So what we need is basically somewhat of a unifying theoretical framework that obviously nobody wants to work on. Oh, sorry, I was going to slide that to the next slide. Okay? So what are the contexts? To make this even more contextual in terms of the challenges that our team, our collaborators both at UCF, in Florida, in the US, and around the world are challenged with, is that if you look at all those labels of the snippets, these are some of the contexts that we work in. Sometimes it is a middle-skilled student learning about microbiology. So it's not just self-regulation, they're trying to self-regulate while engaging scientific reasoning and learning about microbiology with a game-based learning environment, okay? Or if you look at the other extreme, okay, it's a human digital twin talking to her digital twin, that's Megan, by the way, okay? So the question is, what is the role of a human digital twin in terms of modeling and fostering and advancing that particular human self-regulatory process, right? So all of a sudden we have an interaction going on, right? In some cases, and we'll talk about this today, is an NSF that we're currently negotiating, is simulated learners, right? Imagine an 11th grade algebra student who's suffering in terms of not being academically successful in doing algebra, but they are basically teaching their own simulated learner how they would solve, so they're teaching them the algebra knowledge and skills, the problem-solving skills, along with their self-regulatory processes. Like at this point in time, if I don't get the right answer, I'm gonna get really frustrated, right? So help me with that frustration. So being able to teach that simulated learning, because then it is an embodiment of who you are as a self-regulated being, okay? And it goes on, and sometimes we take the multimodal, multi-channel data. You see the heat map on the bottom, and the question is, what a waste of multimodal, multi-channel data, because we're using it as scientists, but why don't we take that multimodal, multi-channel data, repackage it, and give it back to the learner so we can potentially accelerate the development of self-regulated learning? So when you tell me that I'm not really understanding how the text and diagram go together so I can answer that science question, why don't you show me where I'm paying attention to, right? Does that make sense? Yes? Trying to get some feedback from the audience. So it's not unidirectional? Yeah? Okay, all right, good. It's getting hot in here, yeah. So if we look at the landscape in terms of the learning technologies that currently exist and have historically existed, this is a chapter I did with Megan in the Handbook of AI in Education that came out 2 years ago. There's another one coming out soon. There's an update thanks to Gen AI, so we have to update the chapter. So those tend to be the 6 top learning technologies. We have MetaTutor on the top right. I use pedagogical agents, but all it does really is support and detect cognitive metacognitive processes. But our students also express anger, frustration, but here we are. So we have a system that provides partial support, but is not complete. It cannot support right now motivation, like, are you interested in learning about veins? Like, do you even care about veins, etc. Or you have Sue Lajra, my advisor that just retired, BioWorld, which is for medical students, scientific reasoning. We also work with Crystal Island, so you have a game-based learning environment where there is no scaffolding. You're allowed to wander everywhere, okay? And the question is that very efficient in terms of you basically wandering around and trying to figure out and learning everything you can, because you cannot leave the island until you solve that case, okay? Or the bottom left, for example, that's our colleague at Vanderbilt, Gautam Biswas, who uses Betty's brain. So the kids are learning about nitrates and phosphates and then populating Betty's brain, so it's a learning by teaching. So here's the dilemma. These environments all have different conceptions and assumptions about self-regulation, metacognition. They all have their own instructional models, okay? So we use mental models versus, for example, learning by teaching. They have different tasks, different domains, okay? Different time spans, and yet, how do we put all that together in terms of comprehensive understanding of metacognition and self-regulation and learning technologies? And the bigger question is, where does AI fit? Is the role of AI really to be able to detect that from the multimodal data and to support students by providing immediate and adaptive scaffolding? And what does that look like? Because that has many costs, okay? And not just money-wise. So in terms of one of our largest success environments has been MetaTutor, okay? So MetaTutor has been around for 15 years. And then recently we published about 2-3 years ago a synthesis of the work for 15 years, and the co-authors in that paper, including Jason Harley, who's here, were all my former students and postdocs, and also some current students and postdocs that were critical in leading some of these papers, either on affect, metacognition, emotions. And that has led also to some of the recent work to new generations of using pedagogical agents that actually look a little more human-like. I know she still looks a little canary-ish, like a little birdish, okay? But it's the use of facial expressions to actually engage the student and to use facial expressions as information that I can use as to whether I'm being led in the wrong direction because there's some kind of, misinformation, if you will, in the text, or the text and diagram don't completely correspond to each other, okay? So there's also an evolution of different agents. I'm not going to get into that. That's a whole, and that's been led by Megan. and some of our team members. So let's get into some of the work that, for example, Cameron has been leading. This is a multi-university, it's 5 years, and also with colleagues at Copenhagen. Parallel program is, this is a project that's funded by NSF, and the idea here is to teach parallel program, which apparently is very challenging, even for computer science majors, okay? So they've developed an environment, and our role is to collect data, all right? Is it effective? Oops. So here is an example of multimodal data, right? All you're seeing here is a screen recording, okay, of a college student, right, trying to go through a different level and learn about very complex aspects of parallel program. So the question becomes, if you only had screen recording, which you see here, plus the eye tracking data, that little thing that's going crazy, that's not a virus or a worm, that's their eye tracking data in real time, okay? So the question becomes, okay, this is a little bit better, okay, but is it sufficient for us to really understand the metacognitive and cognitive processes that the student, versus if we had screen recording, eye movements, facial expressions. If you see the box, that's doing facial expressions of action units in the face, and like, for example, they're really confused or frustrated. And then what you see in the bottom here that looks like an EKG is, if you were to zoom in, is it actually gives you the electrical activity data. So we're getting multimodal data, but guess what? There's no think aloud protocol. So the question is, if we added language, would we have even a more comprehensive and better understanding, okay, of these processes, all right? So the question becomes, how do we collect this data in context? And this is a laboratory study. Compare that to now, that was one human, right? Sorry, I'm gonna call all of us generic humans. What happens if you have multiple humans, right? So here, just to contrast that with, for example, here is, we presented this on Monday as part of one of the symposia, is you're watching, okay, this is a high-fidelity mannequin, okay, of a newborn who may die, okay, this is an emergency medicine, and you're watching this from the perspective of the team leader, and you're seeing his, in this case it is a gaze behavior, okay, as he is monitoring the monitors, he's monitoring the checklist, okay, because they're children, sometimes you have to use different formulas, you cannot use the dosage administration for an adult, or you'll kill the child, okay, and monitoring what they're doing, etc., right? So, is eye tracking enough? Or and this is real-time data, right? And on this side, what I'm about to show you is not only more data,
and then do like the 1, 2, 3.
So you're hearing the team leader, who's the guy in the glasses here, that's the guy talking, all right? And you're watching his eye tracking data, all right? And what you're seeing is not only the eye tracking, but you see the colors. Those are the areas of interest that have already been delineated. And Cameron is squinting at me because this is very, very, very difficult, and Megan is very, very difficult work to do, and also, the work that Matt has been doing, difficult work because these dynamic areas of interest, have to accommodate the fact that we are dealing with a dynamic environment that keeps changing. So we have to account for that, okay? So, challenge of, we not are looking at the team leader, but also the entire team and the context, okay? This is not a kid doing math on a worksheet where the paper's not gonna change and the ink is not gonna change, right? The environment itself is also providing cues that may impact self-regulation, right? So, individual self-regulation, if you will, metacognition, team, all right? And then we also, here's another challenge, is that we work across different contexts, right? So the top left is a typical instrumented student, right? We collect data on physiological data, log file data to millisecond, the self-regulation palette, we collect facial expressions, concurrent think aloud protocols, okay? And depending on the type of environment, there might be additional content, such as the dialogue between the human and the pedagogical agents. Sometimes we're very limited, like over here with this student, this is a high school student. As you can see, there's no space to collect data. So we're actually collecting data in the wet lab in the high school, okay? And here's when we have impoverished ability, right, because of contextual and pragmatic issues. So they have an eye tracker, luckily for us, embedded in the VR headset, so we can at least collect eye tracking data. But now we can't collect facial data because the face has been basically occluded. They can give us a think aloud, so we can hear what they're doing, and we can detect problem-solving strategies, etc. But here's the other problem. In terms of strategies, they're engaging in nonverbal behavior because they're learning how to synthesize elements to create new compounds, right? So how do we take that nonverbal behavior and actually understand whether that student is using effective problem-solving strategies and is monitoring, regulating her learning of chemistry properly? Other environments that I'll show you in a couple of slides includes very sophisticated viral transmission maps of the US. And so moving along. So here's the example of the outbreak simulator. And so I'll just let you watch a little snippet because we're going to spend the next few slides related to this particular project and how it relates to metacognition self-regulation.
In this demonstration, we will describe an interactive epidemiological simulation that is intended to help identify and correct user misconceptions related to infectious disease and public health. The user can select preset model parameterizations for known pathogens or customize the parameters however they like. The user begins the outbreak at any location on the interactive map. Our simulation runs epidemiological compartment models on spatial population data, allowing movement of infected individuals between grid cells. Models can be spatially modulated by additional GIS data layers of environmental and social variables, such as topography, water bodies, vaccine hesitancy, and access to healthcare. Here, we show a brief example using a fictitious virus that turns humans into zombies. We assume that the virus transforms an infected person into a shambling undead who can infect other people through bites and travels only by foot. The intensity of the red color represents the relative number of infected zombies. Yellow indicates exposed individuals who have been bitten but not yet turned. Black shows regions of the map that have become depopulated. We see that our model predicts a pretty dire outcome for the eastern part of the United States, but the west remains unharmed and the infection burns itself out after about 90 days. Roughly 218 million people have died, about 72% of the US population. Alternatively, here is what happens if we let our zombies get on board planes. We plan to develop an AI-based narrative agent for the simulation that can identify misconceptions held by a user and customizes their interaction options to best facilitate remediation for that individual.
So what does that look like when we have a student? Okay, when they come into the lab, for example, starting lab studies, right? A student that's fully instrumented using zombies, simulation outbreak. And this is what it looks like when now you hear think aloud.
How many vaccine doses per day average could be delivered for this simulation?
So the student setting the parameters for the virus, okay?
How complimentary about this?
Collecting
this is definitely closer to a random guess than I'd like it to be.
Okay, so we're capturing a lot. The verbal rate is so rich in terms of really understanding what the student knows, doesn't know, misconceptions, their planning, and after they set, I'm going to fast forward this a little bit, after they set up their model, they can actually unleash, sorry, that's probably a bad term, unleash the virus and see the effects and make inferences on the data visualizations that they're seeing, right? So we would ask a very simple question that we would ask is the student actively monitoring and effectively monitoring and regulating their CAMS processes as they use this environment, right? And if not, then what kind of support can we use by using these artificial agents? So from that kind of data, right, we can collect lots of data. That's just the sample data. Of course, don't forget we include also learning outcomes and self-report measures. But the hard part is there are many, many, many challenges that we've all experienced and continue to experience is the challenge in not only the detection, but the measurement, the tracking of the model. And who's doing the tracking of the model? Is it just the human or is it the human and in this case, the simulation environment, right? There's got to be some kind of symbiotic relationship. And then the question becomes, if this kind of environment is not successful, then how do we support and foster student self-regulation along with scientific understanding and reasoning that is necessary, okay? So, to sum up, is when we are collecting multimodal data, we have lots of signals, metrics, and indicators. I mean, there are plenty. This is just a snippet. This is obviously not an exhaustive list, okay, of different types of physiological signals, behavioral metrics, metacognitive indicators, affect motivation indicators, and also let's not forget that context, because SRL metacognition is also contextually driven. We have to account. Our challenge is what aspects of, first of all, how do we define context, right, and which contextual cues, factors, variables need to be also included in our modeling and our understanding of what is going on between a human and an AI system, for example. Did this on purpose, right? Inundate you with this is, so this is just a snippet of data that from our lab, but of course there are many, many other labs, Jason's lab, Santa's lab, Maria's lab, and several other folks that are here, part of the EARLI community and other communities, is when you look at the red lighting, okay, it's basically a data channel. So the top, if you just focus on the top one, that's log files. In brackets are the kinds of CAM processes that we can make inferences about from that particular type of data channel. Below it is the type of metric. It's not an exhaustive list again, okay? So from log files, we can look at the frequency and types of interactions, let's say with content, whether it's text, diagram, or an agent, okay? The duration of engagement. And then right below it is the kinds of inferences that we make. And don't forget, we are in the business of making inferences. We're psychologists, right? We're making inferences based on multimodal, multi-channel data. The cautionary note is, how accurate are those inferences that we're making regarding those underlying metacognitive, affect, motivational, and cognitive processes given a data channel, or do we need to go across different data channels so that we can have some kind of redundancy and increase our level and accuracy in making inferences? So as you can see, there's a lot of redundancy in some of these data channels, but they all produce different, so the metrics, think of the metrics as the types of mechanisms or processes that you'll be using and analyzing, or the dependent variables that you'd use in our statistical analysis. So we have lots. I know there's the trigger paper that, for example, Sana and Allison just published, okay, and somewhat related to the handbook chapter that we did for Dunlosky and Rawson, which was the handbook of cognition and in education, where we started listing things like, are we looking at the quality or the quantity? Is it frequency? Is it duration? Is it latency? Is it a macro, metacognition? Is it micro, judgment of learning, which is a type of metacognition? Or do we go even further? And this is a lot of the work that based on Jeff's work, my work, Jason, Megan, I mean, we've started, and Darren Dever was my former student and colleague now, collaborator, or do we go to the micro level? So metacognition is the macro, JOL is a type, so that's the micro level, and then we have to go to the valence level, because there can be judgment of learning at JOL, it can be positive or negative. When a student utters, I don't understand this, that's different than I understand this, and we need to get to that level. But when do we have to fluctuate between those levels, right? Because a lot of the talks that we hear, and I'm not talking about here, but in general, it's like, oh, we talk about metacognition as this like unitary macro level process. No, it is very nuanced, okay? And there are at least 12, 15, depending on the coding scheme. Maria has a coding scheme, Inga has a coding scheme, Jeff has a coding scheme, so we have a lot of coding schemes. And if you look at the differences in those coding schemes, it's also in the specificity and the granularity of those processes. So there's been some major landscape mapping, if you will. So we've done, if you focus just on the top, the detection, right? We've accomplished a lot in terms of a field and several fields in the last 15, 20 years of trying to identify these processes using the multimodal channel data. However, there's still lots of challenges. I'm just going to focus on that. I'm trying to also regulate my time. The other challenge is we're still in the business as a science of learning of describing. We're descriptive. We're describing. The student did this, then they did this, because we can tell from their eye tracking or from the physiological data, et cetera. When are we going to get to the point where we can use the multimodal channel data and be able to predict? If I see this gaze behavior again for X amount of times on this particular interface, that's going to predict that this student in 5 minutes from now or an hour from now is going to engage in more accurate metacognitive monitoring. We're not there yet, right? All right, so the predictive aspect and the explanatory aspect, okay, this is where we need to go, okay? We're spending a lot of time on descriptive, and of course, there are all challenges with that, and that's okay. There's also in terms of adaptivity and personalization, because when you think about AI, well, we're collecting this data not just to feed, if you will, the theoretical models that we have, but it's also to feed the kinds of instructional support that these ALTs would have, okay? So there are many challenges. For example, concurrent thinking law protocols. Of course, they're very rich because it's language, right? I mean, you're literally revealing, if you go back to cognitive science, it's like you're revealing what you are doing by actually talking. Yeah, but complex verbal data is hard to do. It's hard to collect, it's hard to analyze, and it creates a bottleneck. How are you going to analyze, think about data in real time to be able to provide feedback, for example, on real-time data? So that's just one. So there are many challenges still for adaptivity and personalization, and not just in terms of the kind of data channel, but also in terms of learning outcomes and self-report measures. And then it kind of as we transition into some of the recent projects that we're focusing on. So some of them are focused on teacher dashboards, just like, for example, we're collecting all this multimodal, multi-channel data to build more intelligent learning technologies. But the question is, why don't we take this data, okay, and create dashboards? And of course, there's much work done on teacher dashboards. But, as we work with teachers, obviously, we don't want teachers to figure out, like, okay, like, oh, there's eye tracking data. Like, what am I supposed to do with that, right? So we work with teachers to truly understand so that we're designing actionable data visualizations of their students' self-regulatory processes that are collected, for example, in the classroom, okay? And the question is, what kinds of data does a teacher want to see? How do they want to see it? When do they want to see it? And then this here is, we're going to instrument the teacher because that's what he told us you want. Right? And the question is, do you actually, when we provide that data in the classroom, are you actually inspecting the data? What inferences are you making based on your analysis? And are you closing the loop? Is it actually changing your instructional decision making? Okay. Other work that we do with our collaborators, especially school systems, is what does the future classroom look like, right? In terms of multiple agents, LLM generated agents, digital twins, simulated learners. We also, on the bottom right, is part of the Cella. So, think about AI as a topic, right? We focus on chemistry and biology, etc. But AI is a topic, and so it's basically learning about AI with AI tools. So, for example, using the Flora engine that Maria, Inga, and Dragon developed, that we're now using, myself and Santa, and the 5 of us now total are using as part of the Cella project, right? Where you have kids learning and continue with the multimodal, multi-channel data. The other thing, the secret sauce that we have is with these systems, so for example, whether they're learning microbiology, sustainability, or parallel programming, especially in serious games or game-based simulation environments, is that when the student gets any kind of feedback, okay, is why am I getting that kind of feedback? Why are you telling me that I'm not reading the right thing or I'm not, I should maybe replan, come up with a new goal? So the idea is to use the concept of open learner models that Judy Kay, actually University of Sydney, developed, is we're making the assumptions that the behind the scenes, the learner model that these AI systems have, is let's make that visible to the learner. So now by being able to inspect, I'm getting this kind of feedback because the assumption is that it thinks I'm not really good at metacognitive or let's say using some kind of regulatory process, right? All the way from, and that should trigger metacognitive awareness, all the way to negotiable, where the system presents that, and the kid can say, well, you know what? No, the system, you're wrong. You're making the wrong inference and assumption about me, right? So I'm going to challenge you. And you always allow the human to override it, okay? And of course, there can be obviously issues with that. We're also exploring other immersive virtual learning environments, kind of thinking about them as learning, teaching, research, and training and assessment tools, right? So imagine you're the high school kid who's got problems with his physics homework, right? It's 11 o'clock at night. Your parents are asleep. If it's my kid, like, don't come bother me with physics because I failed physics. Teacher's not around. So imagine being able to go into a virtual environment. Well, all of a sudden, I have a metacognitive agent, right? That can do it almost like a medical triage. Like, talk to me, tell me what you're experiencing, etc. And you go into a metacognitive room, virtual room, and you can get all kinds of training and education on what metacognition is all about. Okay, that can help you with your homework. Other environments. So, for example, in the U.S., think about women in STEM and identity formation and gender issues. So imagine you're African American high school student, right? You all of a sudden create an avatar that looks like you, okay? And you're in this immersive environment where you're learning clinical skills, right? But you're not just learning clinical skills in the immersive environment. Guess what? You're instrumented. So you're actually living multimodal residue. Here on the bottom is an example. Because we are collecting eye tracking data, we can actually see, let's say after your session, you are leaving residue that either you can use to reflect on the fact that you still need more practice in those clinical skills, okay? But more importantly, it can also be used for the instructor or for the teacher, okay, whoever is evaluating you. So starting to use these tools also as assessment tools, and if you look at the right-hand side, that's just a list of the types of data that we collect. Either, this environment is called Infectron, so it's either prior to using the environment, during, where you see only multimodal data. This is usually pre-test, post-test, as you see a lot of self-report measures and other outcome measures, and then other measures related to career and in the STEM fields. Now we kind of jump into the human digital twin, which I mentioned earlier and previously that this is a major effort in a university coming from our president, is myself, Megan, and Matt, for example, been focusing really on human digital twins for K-12. So human digital twin is a replica, okay, a computational model of the human, and what we're trying to figure out is how can we embody the CAMS processes, okay, in the human digital twin, so that they can be able to teach, train, model, simulate, and they can actually learn and reason. And imagine your human digital twin also being able to reflect and explain, so that I can actually accelerate my development, not only my domain knowledge and past performance, but also self-regulatory and metacognitive processes. So some of the work that we're doing I don't have time to expand on this, is in the area of K-12. So for example, one of our Seminole County Public Schools, one of our major school systems, is interested in developing human digital twin of an high school algebra teachers, because teachers are not being apparently very well prepared, right? But yet we put them in classrooms to teach math to students, all right? So how can we do that? So it can offload some of the teaching of algebra, but also deal with some of the mundane things. So they can do things like predictive modeling, they can engage in strategy recommendation, scaffolding, and then also optimizing the path as they accumulate more and more data on each student. This is some of the environment. I showed this slide, I think it was yesterday. So human digital twins. So imagine a high school student who's learning about cell biology. Again, it's not just self-regulation, metacognition, but then it's learning, in this case, about cell biology. Or there's the high school teacher, right, with their human digital twin. What is the function of the human digital twin in supporting that high school teacher? Or, for example, some of the work that we're not going to really elaborate on here is the work that we deal with at the Department of Defense in terms of military. So you have a tank crew. Now we have a fourth member that's going to be human digital twin to basically optimize mission goals, okay? And because we also work with patients and medical students and residents and clinicians, is in the bottom is some of the healthcare applications. So imagine you've been diagnosed with cancer, right? Obviously the medical staff is not going to have much time to deal with you, but imagine now that you can collaborate, okay, and actually talk about treatment options, so that we're empowering the patient in making good decisions, okay, and not just the doctor telling you what they're going to do to you. It could also be a nurse practitioner. In the US, nurse practitioners play a huge role. In fact, the prediction in the next 10 years is that there's going to be a decrease in clinicians in the medical fields, right? But there's going to be an increase in nurse practitioners. So nurse practitioners are going to take a lot more responsibility. In the US, they can also diagnose, okay, and prescribe medication, which, for example, when I grew up in Canada, you can do that. That's not what a nurse does. So the question becomes, here's a nurse practitioner basically explaining the differential diagnosis to perhaps a novice nurse practitioner. Okay, and some of the work that we presented on Monday at the SIG symposium is in terms of when you have a dynamic, high-stress environment where somebody can die, in this case a child, which adds another layer, okay, to the sensitivity of dealing with death, and where you don't have all the time in the world to figure out, if this person has gout or not. Okay, this child will die. So the question is, can we use a human digital twin that is able to collect even more data faster, more accurate, make inferences, and then provide basically support for the team leaders so that this child, for example, does not die, all right? Other roles that we see here, so we work top right, not to repeat, is College of Nursing also. This nurse practitioner, who is a very highly paid, highly expert, is basically watching in a lab how nurse practitioners are basically practicing under ultrasound Doppler guidance, a very sensitive and precarious medical intervention. Okay, so the idea is that as we work with the College of Nursing is, can we not replace but augment their training and education by using human digital twins? And then we get to simulated learners. So we see simulated learners basically as a subset or the classification of human digital twins. Okay, for this one, for example, as you see, the approach here is that imagine you're a kid and you're an instrument, and I know it looks creepy, right? All of a sudden you're going to be wearing like a Cooperall, like a hockey. Hockey is not the right, no. Okay. You're going to be fully instrumented, okay? Imagine wearing all these sensors on you, the environment having sensors, okay? So imagine, how we're going to get the learner to basically maximize their learning and self-regulation simulated learner. So, doing explicit training of their SRL and algebra to their simulated learner, right? So we get to see, so you basically imagine they're revealing how they self-regulate and what do they know about self-regulation metacognition that we can capture. Phase 2 is, now they go into vicarious learning. I taught you all the algebra. I taught you all my self-regulatory skills that I would use to solve this problem. Now they get to see their simulated learner actually enact that, right? In some cases, the simulated learner will do exactly what you said you would do and how you would solve this problem. And in some cases, it will deviate because we want to figure out if the student is being attentive. right? And the whole idea is that then the student goes into this interrogation mode, okay? After you're going through this is ask, so if it was not successful, then why was I not successful? What other approaches and strategies? Was it that I was ruminating and not engaging in good emotion regulation, right? I was so ruminating so much because I was so trying to persist on this that you need better emotion regulation strategies. So basically then there's going to be an interrogation, and then so you interrogate your simulated learner, and then it can model better strategies, and you go through this cycle, and this is not meant to be linear, right? And then at the end, basically, as you go through this cycle, one idea is how do we integrate this into, let's say, a regular curriculum, right? Going beyond a laboratory type study, whether it's K-12 or college or really even professional development. And then the simulated learners prepare the humans for more complex algebra problems. In addition to adding that is, what about teachers, right? There's, so Braha Kramarski came out with that model of SRL and SRT, right? Self-regulated teaching that Tove and I have been trying to get funded on an immersive environment, right? So how do we bring self-regulation, SRL, and self-regulated teaching into this environment, having an immersive environment that actually allows the teacher to practice not only their self-regulation, because they are also learners, right? But then how do they translate self-regulation into self-regulated teaching in terms of fostering SRL in their students, right? And then, as we're kind of wrapping her up here, we're looking at many, I know these are very creepy, and I did this on purpose to see if anybody's awake or if you're still digesting your breakfast. Very creepy images on purpose, okay? If we really look, the ultimate goal is the one on the right, right? Can we get AI systems, right? The ultimate goal, one of the ultimate goals is to reflect on their learning and performance and self-modify their cognitive architectures or metacognitive architectures, right? And can they adapt to any context? And then can they explain, right, theirs and others' learning and performance and to derive better solutions? And of course, we ask fundamental questions, right, that we're not really spending time here, privacy, ethics, et cetera, especially with multimodal data. But fundamental issues that we still ask: where is the intelligence? What is intelligence? Where does it reside? Who? Okay. Now, kind of finishing off here with some. I just want to highlight some of the issues. We're not going to go through these lists, right? But just want to say that even though we as a field, not just us, advanced, we still have a lot of work to do, right? So I kind of want to break it up into several issues. So we have many conceptualization issues, right? We're still trying to define metacognition and SRL consistently, right? Pat Alexander's talked about this, Dan Dinsmore's talked about this, Jeff Green's talked, so many of our scholars have talked about this, right? We kind of use it interchangeably. If you notice, I did it on purpose, the title, it was metacognition and SRL, right? And it's not like, well, is it one or the other, okay? So you see that. Distinguishing between phases and cycles, right? We talk about our work, for example, in Sana's work and Maria's work and our work and others. We talk about events, we talk about cycles, we talk about phases. What's the difference? Or sequences, okay? The interplay, motivation and affect. Our biggest challenge right now is, we kind of have a handle on cognition and metacognition and emotions, but how do we handle the motivation aspect, right? Motivation is not going to change, hopefully, at the millisecond level, at the second level, at the minute level, right? But if we don't have experiments that are long enough to capture changes, let's say in self-efficacy, then we're missing self-efficacy, for example, or changes in interest, okay? And then the other big issue is the dynamic nature of SRL, and it's also contextual, right? If you think about stuff in data science, they talk about the 4 Vs. Well, that's one of our challenges. The volumes of data. We have multimodal data. It's like volumes of data that we have, the variety of data. Eye tracking. It can be static, it can be dynamic. The velocity, that's the sampling rate. If I'm sampling my eye tracking at 500 hertz, that means I'm getting 500 data points per second, okay? Meanwhile, if I have an EDA bracelet, that's usually 30, right? So how do I temporally align 30 data points in 1 second versus 500? And 1 second is not going to be long enough for me to make any kind of accurate inference about, let's say, perhaps cognition, metacognition. So how long do I have to sample, right? And how do I temporally align this data? And what clusters of these data channels and the cross-data channels within data channels are informative? And there's a whole ton of other ones. Theoretical issues, right? There's the temporal scale issue, the granularity issue is really important, right? And then I really want to pick is on the theories of SRL in ALT. We have so many different learning technologies, but the question is we're also limited by the affordance of the technologies. Like if you look at a traditional intelligent tutoring system, right, there's going to be very limited in that can do, right, in terms of trying to foster and support adaptive scaffolding or that's related to metacognition, versus if I use an immersive environment, okay? So even the affordances of these different types of technologies will impact the types of multimodal data and the inferences that we can make about self-regulation and metacognition, right? And then the role of, obviously, the humans and artificial agents, which gets us to issues of, we have wonderful models, right? SSRL, CoRL, external regulated learning. Those models are wonderful, but they're really focused on human to human, right? But as soon as we stick an AI agent in there, right, if we do not define what the AI agent's capabilities are, skills, potential, all right, then how do we change those models to accommodate the fact that these agents are not human, okay? Methodological issues, right, these, as you see, I mean, they're getting more and more complex, so it's easy to do in the lab where you can constrain, and we have, well, the illusion of true experimental control, okay? But then we go into the wild, cognition in the wild, right? We can't take this because it's either too expensive. We can't afford to have this kind of instrumentation in a classroom of 30 or 40 students, all right? So as we scale back the different types of data channels we collect, what does that have to do in terms of the types of inference and the accuracy of inferences that we're making in terms of self-regulation and SRL? And then if you notice also, yes, we can, here's a typical experimental paradigm, if you will, for the MetaTutor. That's the diagram on the bottom. So we are very careful about where we place the self-report measures, which ones, the sequence, the learning outcomes, the performance measures, okay, along with the multimodal data, which is captured in day 2, that's the majority, and then the assignment of post-test of the same self-report measures. And that's wonderful. But that's a 90-minute experiment. That is not long enough to show on a typical study that even though you are the best self-regulator, right, show any kind of learning outcomes in terms of significant gains, okay? So what does that mean for us? We're having a hard time, obviously, synthesizing across different types of studies and ALTs, multimodal, multi-channel data, So for example, here's an example of, here's a student, now you got the audio. Here's an example, okay, parallel, the work that Cameron's been leading. I don't know if you can hear this kid.
You can toggle on the links to display all the time while you build your solution. To turn it off, simply click this button in the sidebar.
Okay.
Display all the time. Okay, I'm not sure what that means, but
Okay, so metacognition, I'm not sure what that means, right? Just to give you a snippet. So imagine, did this on purpose at this point in time, how much more and a better understanding we can have if we include language, okay? And so here's the addition of a concurrent think-aloud protocol. But the question becomes, do we need more data channels? What other data channels, right? And if so, why? Is it because we're trying to refine our theories and models, right? Or is it because we're trying to engage in instructional scaffolding where we need a lot more description and understanding at a minute level of what's happening here? Analytical issues, we're faced with that, individual versus group analysis, the temporal, time series analysis. Of course, there's an emergence of complex dynamical systems that has been used. And then we're also borrowing from other disciplines that don't tend to talk very much to other disciplines. So, for example, multimodal, multi-channel data, and then learning analytics. And then on the bottom is an example of a paper that just came out, synthesis by Suzanne Demoji, who's one of our postdocs on the Cello project, who basically synthesized the MetaTutor and the Flora, and then trying to basically map if people are just using one data channel, multiple data channels, and which of the CAM processes are people focusing on, okay? So a lot more work that needs to be done across different data channels. And then, of course, we got a slew. I did this on purpose to finish. We have so many challenges when it comes to providing adequate, effective instructional scaffolding because, again, we are dealing with machines, right, that have their own limitations and embodied artificial agents that have lots of limitations. One thing that I want to point out, too, there are two things here. One is the rules for it. We don't have any rules for adaptation. Right? So let's say we collect all this multimodal, multi-channel data, and you have sorry for saying this, don't mean disrespect for student, the worst possible student, right? No cognitive strategies, no metacognitive skills, low emotion regulation strategies, right? And really no interest in learning this stuff, okay? No self-efficacy for these strategies. So even if we're able to detect that student, identify that student with the multimodal data, our instructional models are impoverished. They do not specify which of those 4 things should I take care of. Because I'm not going to start, I don't think, modeling effective cognitive strategies, right? So do we have to tackle motivation first and emotions, followed by cognition and metacognition? So we have no idea which to tackle, which ones to tackle, when to tackle, why, and then figure out, what is the proof in the pudding? Are the interventions effective? Okay. And then the last one is the teacher professional development that we're getting more into is we need to train teachers basically about self-regulation. I know, for example, in the US, I don't want to generalize, I'll generalize to Florida. Sorry, I shouldn't have rolled my eyes. Teachers are not being trained about self-regulation. They're still being taught about, I wouldn't have to say the word. The acronym is LS. You know what that is, right? Yeah, we're not going to say it. Okay, learning styles. No, do not go there, okay? So can we teach them about self-regulated learning, right? And then how do we design tools, effective tools, right? And some of our colleagues here, like Dover, for example, has been doing that. Effective tools to enhance teachers' understanding of their student self-regulation, but also their own self-regulation metacognition. So a lot more work needs to get done in that area. And then, of course, we have current interdisciplinary research. So we already talked about the conceptual, methodological, and the role of humans. But, at the top is important because all this work is not just about providing evidence for science, but it's really addressing major societal issues, right? Like, for example, Gail and Jeff are focusing on, let's say, things like misinformation and a lack of scientific literacy skill. If you see a lot of the work that's been published on Gen AI, we're starting to call students metacognitively lazy, right? Because, hey, I don't have to express agency. This thing is going to give me the answer. I'm just going to copy and paste it, right? So what are we doing in terms of agency, in terms of developing these critical thinking skills, developing metacognition, et cetera? And then this really boils down to, really establishing a human symbiotic relationship with the AI system. And then last slide is the open challenge and future directions. So the metacognitive authenticity challenge, right? We're trying to design systems that foster authentic metacognitive awareness, monitoring, and regulation, right? Different than the types that the system can do. Multimodal integration paradox, right, is important to do all this. But how do we really integrate this in real time when you have so many different constraints? The personalization and transfer, we've done a horrible job of actually showing transfer. We continue that. Now that's been a continuation of the history of cognitive psychology. For example, Gen AI partnership and collaboration, right? How's the evolving co-regulatory mentorship help the students develop their own collaborative skills? And then the temporal complexity and of learning of measurement. And I'd like to finish off with thanking you for obviously your attention and that this work is not possible with a wonderful team back home and also with our collaborators both in Florida, the US, Canada, and also around the world. And I thank you so much for your attention. Thank you.
Down here?
Yes.
Congratulations.
Oh, thank you so much,
Thank you
Gail.
very much. This
Thank you,
is a
Gail.
present from EARLI.
Oh, thank you, Gail.
And
Appreciate
we
it.
have a lot of time for questions, and we will give you a moment to think, and we will have microphones so you can come up and ask your question.
Thank you, Gail.
You are overwhelmed.
Can you say more about the problem of transfer? So some of the early work on cognitive strategies and so forth showed kids could learn strategies. They were effective in the experimental environment, but then when they went into their classrooms, they did not use the strategies. Have you dealt with some of this and comment on that?
Yeah, no, great question, thank you. Yeah, in terms of transfer so issues, how do we teach/train students to be better self-regulators, right, or metacognitive comprehenders, if you will, right? How do we teach them the declarative, the procedural, and the conditional knowledge and skills that go along, for example, with metacognition, right? Do we, what does that paradigm look like, right? Is it just a matter of, oh, okay, you're telling me that metacognition involves my emerging understanding of, let's say, physics, thermodynamics. Okay, that's great. But that's just declarative knowledge. What am I going to do with that when you actually give me a thermodynamics problem? So do we go now, the next step is, well, it's good that you know about JOLs, for example, judgments of learning, but the question then is, well, how do I actually deploy judgment of learning as my metacognitive repertoire, right? So I need practice now, right, in terms of using that. And then the question becomes, the most challenging part is, the hardest one that nobody really wants to deal with, is the conditional knowledge. Well, under what conditions do I use JOLs? Okay, does that make sense? Right. And can I generalize that? Is it only for, let's say, math word problems or thermodynamics problems, word problems, right? Or what else if I don't have a word problem, right? Do I still use it? Okay, does that make sense? And so the question is, if you're going to do traditional training, like classroom training, that's going to take forever, right? How about also, and your question is very important because if you notice the environments that we build, there's been a tradition in AI and Ed. MetaTutor, it's for college students about the human circulatory system, okay? Betty's Brain, it's for middle school kids learning about environmental science. How about we develop an AI system that teaches students learning to learn, which is really what you're getting at, right? And then what does that look like? But then there goes the question again. Are all the problems going to be STEM-based? Well, what about if I need to transfer non-STEM environments or contexts or tasks and domains, right? So the idea is we need to map that out, if that makes sense. Right, yeah, because single strategy, yeah, we can do it, right? Yeah, I can teach you that single strategy and then give you near transfer and you can apply it. You may be able to apply it far transfer, but there may be some decay. But self-regulation metacognition, we're talking about the fluctuation of those, it's not just cognitive strategies, cognition, metacognition, emotions, motivation, right? So what does that look like in terms of a training paradigm, right? The other issue related to training is that most of the stuff that you see in the literature really is a one-size-fits-all. So even if we had an ideal way of training for transfer and generalizability, is that imagine a student already shows, 5 minutes after 5 scenarios that they know about judgments of learning. Well, guess what? The training system has been developed that you need to go through 30. So now we're going to punish the students to go through 30. So even that kind of environment has to be adaptive. Once I detect that you have mastered the declared procedural and conditional knowledge, let's move on to the next metacognitive process, if that makes sense. Sorry, that was a long answer. It's a complex question.
Another question?
Okay, thank you very much for your presentation. I had a question related to the development of metacognitive skills. I think you probably already thought about that. What if you collect all this data during 90 minutes or longer? What if the metacognitive skills are not developed during the active training, but later, while sleeping or whatever, 3 days later? Did you take that in consideration or for your learning? That means like sort of there's an interaction. But then there are also maybe processes which happens not really like while you are actively or.
Sure.
So how could you analyze that? What do you have any ideas to consider that in this?
Yeah, that's an interesting question. I don't know about sleeping. I wish I can accelerate self-regular SRL development during sleep. I got a USB. But so your question raises the issue of not only that we have to extend our methodological paradigms in terms of our experiments, right? I'll give an example. So easy to do in a lab if you have participants coming in, right, repeatedly, but it's also going to be cost prohibitive. And we know that even when we pay participants, right, no matter how much we pay, if it's like a 1 week, which is obviously a little longer, but not ideal, a month, is that they're going to start petering off. They don't come in. So now you have subject mortality, right? And then that's going to impact your results, right? The idea is to work with teachers, and this is where it's really challenging for us as researchers, because first of all, I am not in a college of education, so I don't have direct link to the schools, right? I do have direct link to the schools, but it's links that I've made. And so in our environment is to work with the superintendent to basically, well, I'll use the word dictate, basically that you're going to work with this particular school, and this particular school you're going to work with these particular teachers, right? But the problem, at least in the US, is that it would be great to have these technologies be used, let's say, throughout an entire academic year. This is where we basically see those qualitative changes and quantitative changes in metacognitive skills and self-regulatory skills. But it's hard because the curriculum is so demanding, right, that even if you ask for 3 days a week, that's too much because now you're interfering with the teaching. So how do we deal with that issue, right? I'll tell you the secret. So one of the secrets of dealing with that is if we work with private schools, because we have private schools, they're like, sure, you want the kids for a month, you can do whatever you want with them. So that's ideal, but let's think about it. Think about self-regulatory and metacognitive skills. When we go into these classrooms, these are not the children who need to be taught metacognition, self-regulation. They know how to do this, right? So this question of yours deals with a lot of the challenges that we're facing. So what is a potential solution? It would be to work with teachers in their classrooms where the students and the teachers would be using these kinds of technologies for an entire semester, an entire academic year, right? That would be one way to try to tackle that, if that makes sense. Yeah. But the sleeping thing is interesting. We're going to now start instrumenting sleepers.
We still have time for another question. How about right there?
Thank you for this very interesting talk. My question is about the disciplinary content. So I come from mathematics education, and I have a feeling that, at least in our domain, less is talked about the interface exactly with the content. And I'm asking, do you think that SRL should be studied differently in different disciplines? Is there any interaction with the content?
Yeah, so that's one of the challenges. If it's decontextualized, is that going to help better transfer and generalizability, right? But the fact that it is contextualized, so the best evidence that we've seen is that for that is that it needs to be taught or trained, right, within a particular discipline, right? With math, with science, it could be chemistry or physics, right, or clinical sciences, right? When you bind those together, the domain and the self-regulation and the metacognitive skills together, right? Yeah. But that goes back to the other question is then can you elevate and abstract that to, if I know how to do that in math and science, whatever, chemistry, physics, can I abstract the principles, right, the knowledge, the declarative knowledge, the procedural knowledge, the conditional knowledge, right, to apply it to any other, for example, STEM or non-STEM discipline, right? Or even lifelong learning, right? Dealing with life situations, right? Relationships, addiction, right? There's a whole lot of area, right, of self-regulation, for example, that deals with clinical issues. Kinds of addictions, smoking, drugs, weight, etc., right?
Thank you so much, Roger, for this very impressive keynote. You blew us out of the water. That was really amazing, this body of work that you presented. Yeah. You presented also your ideas about use of AI and how AI could form human twins or could digital twins and could also use multimodal data to not only orientate towards the cognition of a learner, but also towards emotions and such. And I'm wondering whether you are already thinking ahead towards a theory of AI in education in this respect, because it's like becoming like a human-like interactor. Do we need to consider what here in this respect?
Yeah, no, absolutely. Thank you, Armin, for that question. So one idea is to bring the work that's been done in AI, so for example, the metacognitive architectures that we're using in the human digital twin, to bring that into our models of ed psych and learning sciences, right? And also cognitive psychology in terms of metacognition and self-regulation, like how do we add that? And then we're getting closer in terms, like you said, like the replicas of the humans that we have are getting much more, we have, closer to what we are looking like, right? But not just the physical appearance, but also the internal, right, architecture. So the question, yes, we definitely need more theories that basically extend our theories, and really merge those areas together. So I see that as coming from AI in terms of metacognitive architecture, but also the cognitive neuroscience, right? We need a lot more work in terms of cognitive neuroscience. And that leads to the work that is being led also by medical engineers, which is the BCI, which is the brain-computer interface, right? So imagine me, now I don't have to type, I don't have to pull down a menu that I don't know how to do magic. I want to be able to talk to an artificial agent, like I'm really trying to solve this problem, I'm struggling, right? And I'm struggling because I don't know what's important in this word problem. Can you help me? We want to have that kind of seamless. So how do we include that in our theories, right? And part of that is also bringing in, models, for example, like Sana and Allison have in terms of SSRL, right? You focus the issue on AI, hybrid AI. That's going to be one way for us to start exploring that avenue. Mm-hmm. Yeah. Thank you.
Thank you. I'm over here, sorry. I won't stand up because
sorry.
I don't want to. Thank you for that. Just as a follow-up to that, I'm wondering, I appreciate the CAMS model being front and center here.
Yeah.
And I'm wondering about the affective and social components of this. I'm thinking about a digital twin and peer comparison and social media and the kind of affective and social implications of having someone who is your digital twin that says something about who you are.
Yeah, so that's an open question in terms of thinking about a whole area of research that we can generate some hypotheses. Because if you look at the examples that I gave, right, for example, with MetaTutor, you have this disembodied, two-dimensional, agent that not only does not look like you, right, cannot facially express, just like if we're talking to a teacher or a peer, right, that has no facial expressions, etc. Right. So we're wondering is, and that's an open question, whether if that thing, the artificial agent, actually looks like you, right, in terms of persona, right, but it's not just looks like you, because we're beyond, right, we have colleagues in engineering that are really focused on the physical appearance, right, should it be embodied, should it be 3D? Like in the tank, basically, there is no embodiment, it's just going to be a voice. We don't need a body in there, right? So also adapting that to the particular context, and not only because there's no physical space, but there's no need to have a physicality in there, right? But then the question also becomes, if it's like you and it's a replica, and we can spend forever on talking what a replica is, because in the medical domain, it's a replica of your, like if you're talking about patient compliance, for example, then it has to be a replica of you. You've just been diagnosed with pre-diabetes, for example, right? Now you're facing a human digital twin that has your genome, right? So the question is, well, show me what's going to happen to me 6 months from now, right, if I don't change my eating habits and my lifestyle, right? Well, guess what? We can accelerate disease progression to the point where now, oh my gosh, I actually got diabetes because I didn't make any changes and I had a buffer. Or show me what's going to happen 10 years from now. All of a sudden you come back and you're blind in one eye, or you're missing a limb, right, because you had to be amputated, or your retina. So so the question becomes, what are we just talking about? The genome component, the physiological, neural, right, or the cognitive architecture. If the cognitive architecture, then basically if it is a replica of you, then it's not some other agent. It's really modeling who you are, and with its repeated use, it can accumulate data about you and make meta predictions, right, and scaffolding you through many, many different issues, if that makes sense. Okay.
There's a question right there. Yeah, Daniel asked a very interesting question about, regulation, self-regulation, but I was wondering, how about co-regulation? So you have self-regulation within individuals and teams, but it's not always, with the digital twins, we're getting ourselves, so our own sort of image, but very often in social communication, we see ourselves different, and we sometimes need this extra reassurance or corrective feedback. Yeah. Well, I see that it's spilling over the field, but how about co-regulation?
Yeah, I didn't emphasize that in the talk, but co-regulation is obviously an important issue, right? And co-regulation between humans, right? If you go back, for example, the work that, for example, Sana and, Allison have been doing, especially with, their model of SSRL. Between humans and Hannah, for example, between humans is different, right? So their model is wonderful because it talks about the co-regulatory, socially regulatory process between humans. But as soon as you start sticking in an artificial agent and not a human agent, then the game changes. So it would be interesting is to take their model and adapt it if it's a human digital twin versus a simulated learner, et cetera, because it's going to change. Because that artificial agent, right, is going to have limited intelligence, if you will, and limited capabilities, right? And so if we go under the assumptions of the current models, well, we're never going to be able to derive any real, substantive data on that. So going back to Armin's question, we need to continue working, especially on developing these theories of how AI meshes with our current theoretical models, if that makes sense. Yeah.
Yeah, thank you for that talk. I think you very well highlighted all the complexities and also the challenges that are involved in your research. I was just wondering, like, in your strive to foster self-regulated learning and metacognition, where do you see us stand now? Because there's also a lot of talk about with the role of technology. There's also like declining attention span and distractions. So technology, you have a huge competitor.
Yep.
It's not just a help, maybe.
Sure. Well, that's kind of a general question. I mean, I don't really. So thinking about this, yes. I mean, we have so many competing. I mean, we see this every day, right? People driving. You got, young. I mean, we see this all. People driving. They're texting. They're driving on the inside lane, which actually irritates me. The inside lane is the fast lane. They won't move over. They're eating in the car while watching TikTok or YouTube videos while attempting to drive. Right, so there's all these competing, and the question is, my gosh, what is happening to humans? Are we? I feel like saying, and we talked this, with our team. It's like, my gosh, is driving so boring now that you will have to have some other stimulus? So how do we discipline humans back to paying attention, right? And people talk about multitasking. Well, you're not doing multitasking just because you got 500 windows open. You're not engaged deeply in any kind of cognitive activity. So. I don't know. I'm kind of worried about the future, to be honest with you. If I can just simplify my answer with that, about the humans that we're, raising, about the humans that we're, generating. I guess that sounded very lab-like. Okay, but yeah. What is the future, right, in terms of of humanity? Wow, that was really like Debbie Downer.
Yes, Debbie Downer.
Wow. What's going to happen to us?
Thank you. So I had a question. I got hung up to something you mentioned right at the beginning, and it's related to the digital twin. We said that you're starting to use LLMs to create synthetic data for the twin.
Yep.
Could you elaborate a bit more on what your idea and approach is there?
That will cost you. That's the secret sauce in multiple grant. I'm just kidding, but it is true. So let's say you have a student. We're collecting the multimodal data. At some point, you've sampled enough. I'm trying to make this generic enough so that you're not also giving the secret sauce away. But they're not learning. They're having a hard time simultaneously using a particular metacognitive process of assessing the relevance between, let's say, text and diagram, right, with a particular strategy that should be used along with that, right? So imagine we can detect that because from the repeated pattern, right? But our system right now does not have a scaffolding approach to deal with that. But knowing that there's an AI module in there, right, is that we've been able to detect that. We've been able to detect that in the learner model. There is no scaffolding to tackle that. We can use AI to generate a synthetic eye-tracking gaze behavior pattern that the agent, as part of their scaffolding, can model for the learner. So that specific scaffolding approach was never originally designed in the system, but it can be generated. So that's when we talk about synthetic data. It's data that a human has not actually generated, right? That can be done on the fly, and that can be done now, right? Especially with a more multimodal aspects, especially eye tracking is a great example, or even facial expressions. Like, what do you mean I looked confused, right? Because nobody, like, we never, right? So imagine just basically you have collected the video data. Well, show back the snippet, the context, could be a video. Here's you are solving the problem, and here, look at your facial expression. You were actually confused for, let's say, a minute, right? So using that data also to have the students confront themselves so they can better understand who they are, right? Because we never see ourselves from our perspective, it's always from somebody else's perspective, right?
Okay.
Hi there, thanks for that talk. It was brilliant, Roger. What I'm interested in, the short question is getting it out into the wild, because you've showed us a lot of really sophisticated mechanisms, multimodal mechanisms, and you've talked about think aloud, and this is all fantastic. And I know myself that the nuance that you get from this type of analysis is fantastic, but the limitations are that you can't just detect that in a normal classroom environment without these mechanisms. And if you try to use less obtrusive tools, such as just trace data, then you lose the nuance. So which direction should we go in? Are we going into sort of ground theory based on this amazing analysis, or do we look forward to developing multimodal mechanisms that are less obtrusive, that can be dropped into normal learning situations?
Yeah, no, absolutely. So there are multiple paths that we see in the different fields. One is the going less obtrusive, right? So you have minimal amount of data channels, right? So limited ability to make inferences, right? But it's a context, right? So when we go to schools, for example, you got 40 kids using simulation outbreak, right? For example, the work that Matt has been leading. Well, we're collecting log file data, but there's no multimodal data. We can pull some kids, right? But we can get permission from the parents, right, is to collect facial expression data. So now we have facial expression, but so for example, the parents, when they see the consent form, they indicate which data channels they're giving us permission to use, okay? So that's one way to do it. The other way is a combination of classroom studies, right, where we can collect vast amounts of data. So like in a typical school day, right, you can collect like at least 100 kids' data on them, right, but you only have the log file data. Meanwhile, you continue the study, right, and some of the other kids you reserve for having them come in the lab, right, so it's going to be slower because then you're doing multimodal data and eventually you can mesh that together. Companies like iMotion are, that we interact with and we purchase a lot of their equipment, are trying to basically look at, can we use the same camera that we're able to detect facial expressions, but for eye tracking? But it's not going to be as accurate, right? It's going to be gross level. It's like, oh yeah, the human was looking at this part of the screen. So there are multiple solutions, right? And so different folks, and then for example, with our Archella network and other networks, right, what we're doing is, because some of us have decades of doing this kind of research, is not just hogging it up for ourselves, but it's basically sharing these tools and techniques with others, right? So kind of expanding the international network. If you were at our symposium yesterday, that was one of the things that Dragon pitched, like the next study, right, basically is going to use, students, is going to basically tackle students from different, all 4 continents, all 5, I guess, if you include Australia, right? So yeah, so multiple strategies, absolutely. Yeah, thank you.
So chair's privilege, I'm going to ask Roger a question. Roger, how much do you think teachers need to know about cognition, metacognition, self-regulated learning in order to benefit from all this data? Because in my experience, the amount we're teaching in the US to teachers about basic cognition, motivation, metacognition has decreased over time.
Yeah.
And do you see teachers having enough understanding of these constructs to implement the implications of the data they're receiving from these kinds of studies?
Yeah, no, great question, Gail, thank you. Because of that diminishing of exposure to teachers and their training in terms of self-regulation, for example, metacognition, we need to do more of that. And researchers like us and networks like ours, I mean, we want to, but it's this roadblock of not being able to. Our frustration is we have the tools we want to share. We're not, we're not charging. How do we get into the schools to really work with teachers intimately, right? Because teachers need to learn about these processes. What does it look like? How do we assess it? How do we support it, right? And we're seeing a lot of that. That's not happening. And if you look at our nation's report card, I mean, our trend compared to other, European countries and Scandinavian countries and Asian countries, it's going down in reading, science, and literacy. And so we need to do something, right? So how do we get in and compete, at least in the US context, is we're competing with curriculum, right? And who's making decisions about what teachers should know and not know, right? So yeah, so that's a big challenge. I really don't, we're ready to work with them, but it's like we're missing that catalyst that can facilitate, right? But definitely teachers need to know about these processes, absolutely. Yeah. Thank you.
All right, I think it's time to thank Roger for his excellent keynote address.
Thank you. Thank you all.